So we get to start with a new book today, and this one is going to be the book 7 through 9. Make sure that you get this from the back counter and before you start, because you're going to need it. So we're going to go to page 6, and we're going to talk about angles. The other thing I need you to have is a protractor. So the substitute might have handed one out to you. If not, make sure that you get one. Make sure you also return it at the end of the class so we can use it again in tomorrow's class. And you should be able to finish today's homework in class, so you won't need to take it with you. So we're going to talk about angles to begin with, and hopefully there's a lot of this information that you already know. And one of the things that I want to start with is we're looking at these two angles, and it says which one is bigger than the other. And we'll get to that in just a second. But first I want to talk about an acute angle. And I'm guessing most of you know what an acute angle is, because you're always taught that it's cute. So acute angle, an acute angle, is less than 90 degrees. And we know if it is 90 degrees exactly, it's a right angle, right? And we've been talking about that with perpendicular lines. This little symbol tells me it's a right angle. So a right angle is 90 degrees. Yes? An acute is less than that. So if it hits this, what most people would kind of consider a square corner, then we know that's 90. Anything smaller than that is an acute angle. Then we also have an obtuse angle. And the way that I think of obtuse is obese. So it's more than. It is more than or greater than an angle measure that is greater than 90 degrees, usually less than 180, but we're not going to get into those things right now. So if we look at these two angles and it says which one is bigger, now they're trying to make you think that this B angle is bigger because it is longer. But the angle itself is right here. This is the angle. They might be the same. They're kind of looking that way. And I will tell you, with a protractor, let's look at the protractor too. When you look at a protractor, what you need to understand is that this is where we're going to put the corner, or what's called the vertex of the angle. And then we have to line up one side with this or with this, depending on which way the angle is going. So when I'm measuring, and the reason it's important that you understand acute is because see how it goes from 0 to 90? So if I'm measuring my angles, I'm going to always look to see, is it acute? And then, is it less than 90? And then I know I'm going to use this. If it's more than 90, I'm going to come over here. But notice that the protractor always also goes this way. So it goes from 0 to 180 here, and from 0 to 180 here. And so that's the reason you need to know ahead of time, is it acute or obtuse? So now, let's look at these angles again. So with this angle, remember we take the point right here. See this right here? We're going to put that at what's called the vertex, or the corner where the sides meet. Okay? So we're going to put that right here. Now we can't really tell what it is. So what we have to do is we have to take the straight edge of our protractor, and we have to extend that line. So we're going to extend that line with our protractor. Make sure it actually is the right line. Okay, mine's a little off, but that's okay. And that's just it. When we're measuring with a protractor, we're gonna be within a couple degrees of it. So here we go, line it up. See, I'm lining this side up with this side. I put that point right there, and there's my protractor. I come all the way out here. That says it looks like it's about 46 degrees. Did you see that? And yours might say 45, 47, but right around there. Okay, it's going to be about 46, oh, maybe even 47. But we're going to say 46 for now. Now we're going to look at this one. Now this one we don't have to extend the side because this one is long enough. Put the vertex right here. And remember, the beauty of a video is if you didn't get it the first time, go back and rewatch it. And this one's hard to do. So what I did is I picked my book up with my hand so that I don't crush my protractor. I don't want to break the protractor on the first day of using it. And where does that go? That looks like it's also about 46 degrees. Okay, so they're actually the same size. They're both acute angles. Now the next question says, identify an obtuse angle in the diagram. Well, this angle right here is 60 degrees. That's acute. That's less than 90. This angle right here is 50 degrees. Well, that's less than 90. So neither one of those are. And the way we name them is the 60-degree angle is angle DAC. Angle DAC is the same angle as angle, start over here, CAD. So what we have to remember is the vertex has to be in between the two letters, It doesn't matter which way you name it, they're both the same angle. DAC is the same as CAD. So that is a 60-degree angle. That's acute. This 50-degree angle, BAC, is also acute. But the entire angle right here, okay, going from BA to D, angle BAD, oh, is bad. Or you could also call that angle DAB, DAB. That one is obtuse. You only have to name it once. I'm just telling you can do it either way. Okay, so that, just want to give you some background on angles. Okay, go to the next page, on page 8. Now on page 8, we see a picture of a protractor, very similar to ours. And it says, Tyler and Priya were both measuring angle TUS. Okay? Now the first thing you want to do is you want to look to see what is that angle. If I didn't have the protractor, is that an acute or obtuse? That's acute because look right here is 90. This is 90 degrees and it's smaller than that. So this is an acute angle. And the reason that's important is because when we come over here to look, the angle goes from here up to there. So do I go 0, 10, 20, 30, 40? Or is it the 140? And that's where you have to look at it before. We already said it's acute because it's less than 90, so then it's the 40 degrees. So now, let's look at their question. Priya thinks the angle measures 40 degrees. Tyler thinks the angle measures 140. Do you agree with either of them? Explain your reasoning. Well, Priya is right. We've already talked about that. Have you noticed that Priya is almost always right? I'm not sure what it is, but Priya tends to be right. And so I always look to see, is there any way I can prove Priya wrong? Because she's usually right. Okay, so just wanted to point that out to you. The other thing is just kind of some definition stuff, is when two lines intersect to form 4 right angles, we call each one a right angle. A right angle measures 90 degrees. If you have a highlighter, that'd be a good thing to highlight right there. A right angle measures 90 degrees. You can think of a right angle as a quarter turn in one direction or the other. So a quarter turn if I'm going all the way around. An angle in which the two sides form a straight angle, okay, form a line, sorry, I misread. An angle in which two sides form a straight line is called a straight angle. So a line is called a straight angle, and it measures 180 degrees. So this, from here to here, is considered a straight angle. It is on a line, okay, but the angle itself is called a straight angle. Now, if you put two angles together, two straight angles together, you get an angle that is 360. So if you go all the way around, it's 360 degrees. Okay, so if I go all the way around, that's 360. So a circle has 360 degrees in it. And we'll need to use that when we look at some homework later on. The other information I want to talk to you about is what's called adjacent angles, okay? When two angles share a side, again, if you had a highlighter, this would be a time to pull it out, okay? So what would I highlight? I would highlight a right angle measures 90 degrees, okay? And I would also say that a straight angle measures 180. If you go all the way around, it's 360. And then, when two angles share a side and a vertex, remember the vertex is the point where the sides meet. Point where sides meet. We'll just call it that for now, okay? And they don't overlap. That's important. That's called an adjacent. Those are adjacent angles. Two angles that share a side. Okay? So two angles that share a side. Here's an angle. If I draw this one in here, this makes these two adjacent. They share a side. If they share a side and they do not overlap, angle 1 and angle 2 are adjacent angles. Okay? So I just want to make sure, because we're going to be talking about that in the next one. They share a side, adjacent angles. And we're going to skip over the practice problems. We're going to go on to page 12. I'm on page 12. Page 12 is where we're at right now. Now on page 12, it wants us to estimate the measure of each indicated angle, and then we're going to go through with our protractor. So the first thing I want you to do is look at these and just kind of take a guess as to what those might be. Okay, so I'm just going to pause, you pause, we're all going to pause, take a guess as to what the size of that angle is, and then we'll pull out our protractors. Go! So hopefully it took a little time. So I'm looking at this one going, well, that's almost right. I'm going to say that's probably about 88 degrees. This one, not quite. We're going to go about, I don't know, 75 degrees. I'm just kind of guessing. This one is more than 90, so I'm going to say 100. Okay, we're just kind of guessing. This one looks like it's straight. Is that a straight line? Oh, can't use my protractor line. I would say if this is not 180, then it's 179. This one's less than that by a little bit. Okay, so I'd say probably about 170. This one's more than a little bit, so I would say 190. And again, I'm just guessing. Now this one, okay, look how it goes all this way here. It wants us to measure this angle here. Well, this looks like 90, okay? And if I know if I go all the way around, I would take 360 minus 90. So what is that? I hope I subtracted right. 9 from 15 is 6. So I'm going to say that's about 260. And on this one down here, oh my gosh, look all the way around. There's just a little part that's not. So this looks like it's just about 10 short. So I'm going to say that's 350. Okay? And I'll tell you how we're going to measure that one in just a second. So let's pull out our protractors. Let's see how close we were. And hopefully you already guessed some of your numbers too. So, oh, wait a second. That one's dead on. Okay? That one is dead on. So that is 90 degrees. This was my guess. And when we measured it, we found out that was actually 90 degrees. Okay, here we go on the next one. So line up this dot with that point right there. Okay? And then this segment right here has to line up with that segment there. Again, we might be a few off. Oh, we're going to need to extend that line. Okay? So extend it. Here we go. So if I extend that line, it looks like it's about right there. What is that? That's less than 90, so it looks like it's about 80. Look how close is that. It's kind of hard to tell right now where that is. So that's 80 right there on that mark. Not 100 because it's less than 90. So it looks like it's about 80. Hey, I'm not too far off. Yay me! Okay, now on this one, I'm going to go under my book again, kind of grab it like this, so that I don't break my protractor. Ah, first I have to extend that line. That's hard to do when it's in the crease like that, isn't it? So we're going to put our point right there. We're going to extend that line, and that looks like it's about 98. Pretty close to 100. I wasn't too far off, was I? Nice job, me. Yeah, it looks like it's about 99. Okay, so 1 degree error of margin. Okay, here we go. Is this a straight angle? Yep, that one is 180. Okay, so now, here we go. We're going to measure this. And, oh, extend the side. Okay, so here we go. We're measuring from here, and this is an obtuse angle, so this one's going to be more than 90, so keep that in mind. And it comes all the way out here. That says that it's about 170. Woohoo! I was dead on that one. Nice job, me. Now this one, what makes this one tricky is it's more than 90. So it's more than 180. So actually what we have to do, what I like to do anyway, is I straighten this one out. I draw this as a straight line. And then I measure how much beyond 180 did I go. So I'm going to extend this side too. If you didn't catch all that, pause it, rewind, and go back over it. So what I did is I extended this line because I went past 180. This went past 180. So I'm going to measure what that angle is. So I'm turning my protractor upside down. I'm going to go along that line. And I'm going to say that looks like it went out about another 10 degrees. See how it went out another 10 degrees beyond the 180. So 10 plus 180, hey, I'm getting good at these, 190. Okay, on this one, we did figure it, as long as this is a right angle, let's see if this is a right angle, line that up, it is. See how that's a right angle? So therefore, whoops, This is a right angle right here, so I was right. You take the whole thing, 360, and you subtract 90 off, and it'll give you that angle. Now on this one here, we can't do this with our protractor, the ones that we have. So we're going to measure this angle right here, okay? And then we're going to subtract that from 360. So the first thing I'm going to do is I'm going to extend one of these sides, and again, I'm grabbing my book and kind of wrinkling it up. If you have another book you can put underneath it, that'd be the best way to do it. And I'm going to extend this side. I'm going to just kind of have to eyeball a little because it will not work the way it is. Okay, so now I'm going to turn my protractor upside down. I'm going to put my point there, and this is going to be my starting line. Okay, and how much did that measure? Oh, I extended the wrong side. I need to extend this side. I need to extend both of them, I guess. Or I could just measure off of this. Hey, I could just flip it around. I'm going to measure from this line. So I put that here, line that up, and that looks like it is 10 degrees. So this is 10 degrees. If that's 10 degrees, then I take 360 minus 10, and I get 350. Okay, so hopefully by now you've seen how a protractor works, because we're going to be using those on this next problem. Now this one says cutting. We're not going to cut because I'm not there with you, and we're not going to hand out scissors. So we're going to just draw. So it says your teacher will give you each 2 rectangular papers. Nope, we're not going to do that. What we're going to do instead is we're going to take this and we're going to draw a line. And I want you to choose whatever line you want. Draw a line, okay, from here. From here, I don't care where it is, draw a line. Someplace on here, draw a line. Okay, so I'm just going to draw mine here. There's a line. And I'm going to draw it long enough that I can measure it. Draw your line. It honestly does not matter where your line is as long as it starts from here. Now I want you to measure both of these angles, okay? Measure both of those angles. Ready? So you're going to measure this one with a protractor, and you're going to measure this one. Look first to see, is it acute or obtuse, so you know what to use on your protractor. So this angle right here is obtuse. This angle right here is acute. And when I measured it, this was 119. And this was, wait, let me do it one more time, sorry, forgot my numbers. Yeah, this one was 61. Okay? Okay, so now I want you to take the straight edge of your protractor right here, and I want you to draw a line. Any line, just draw a line. Ready, go. There's a line. Okay? Now I want you to put a point on there, someplace kind of close to the middle, but it doesn't have to be exact, like that. Now I want you to draw a line on there. It can be any line whatsoever. There, I'm going to draw this line right here. Okay? So draw your line. And again, it doesn't matter. This is just us exploring some things, but you'll see what happens. Okay, now I want you to measure both of those angles. Okay, so I'm going to pause. We're all going to go measure our angles. Actually, I'm going to change my line because it came out to be about the same as that. So I'm going to redraw my line. I'm going to make it more like this. Okay, so I'm going to measure it, putting the point right where this is, right here, lining up those sides, and when I go to measure, that looks like it is 19. So that's 19 degrees. Now I'm going to measure going the other way. This one's obtuse, so it's going to be more than 90. So this angle comes out to be about right there. What is that? 161. Okay, I like 9s and 1s. That's weird. Okay, so here's the thing that's really cool about it. If I were to have this, I'm going to add these two together. What did you notice? Okay, what did they notice? This one adds, if I take 161 plus 19, I get 180. If I take 61 plus 119, I get 180. Okay, wait. Let's do one more. Okay, come up here, draw another line. Put a point. And I'm going to draw it almost straight up this time. I'm going to do something like this. I just want to see what happens. Okay, so I'm drawing a different line. Draw it different than we've done before. Measure each of those. Go. Now the problem with mine is I can't extend it, so I'm just kind of taking a guess. That's like 105. Okay, so what I did is when I put it up here, hopefully you'll always be able to extend yours, but what I did is I just kind of drew an imaginary line right there with my pen. Okay, now look at these. If I add these, 105 and 75, when I add them together, I get 180. Okay, that's not a coincidence. That's going to happen because it's based off of this line. Okay, and a line is 180 degrees. Okay, these have a special name. These are called supplementary angles. Supplementary angles. Supplementary angles. Now, the way I'm supposed to say the definition of this geometrically, so if I were in geometry, I'd say the geometry is supplementary angles are angles whose sum is 180 degrees. So, sum is not a word we use every day. So what this means is angles that add to 180 degrees. Those are called supplementary angles. Okay? Now, let's go down here, taking our protractor. This time, we're going to go off of this. You can probably already guess what this is, because what is the degree of this angle right here? Okay, if I look at this angle right here, that's a 90-degree angle, isn't it? Okay, so you can probably guess what's going to happen here. Okay, let's draw a line. Put your your protractors up there. Draw a line. Okay, measure each of these two angles. Okay, so wherever you drew your line, measure those two angles. Ready, go. So I got this one no problem because I could just go here, but to do this one, I have to turn my protractor, and I'm going to line it up right here, but see how I'm turning my protractor off to the side, and when I go to measure that one, that's going to be 17 degrees. And look what happens. 73 plus 17 gives me 90. Which kind of makes sense because we knew this whole thing right here, this is a 90-degree angle. So they have to add to 90. And guess what? They have a special name. Okay, complementary angles. Okay, complementary angles are angles that add to 90 degrees. And the way that it's going to be a definition anyplace else is angles whose sum is 90 degrees. I'm just going to write that out so you'll see those words. Angles whose sum is 90 degrees. Sum and add. Those are connected. So this is the fancier way they're going to say it in a math book. Okay. So we have supplementary and we have complementary angles. Now, if you're like me, it's sometimes hard to keep them straight. So what I did is I tried to find a way to see that. So I see how complementary angles is 90, supplementary is 180. So the way I remembered it is alphabetically, C is smaller than S. So complementary is 90 and supplementary is bigger. Okay, so supplementary is bigger. That's one way. I'm sure there's other ways. Email me those other ways. I'd love to hear it. Okay, so here we go. We're going to find out what these angles are. Use a protractor in the picture. We don't even have to use our own protractor. Okay, we can just use theirs. So they're saying from here to here, how many degrees is that? Well, is that an acute angle or an obtuse angle? That's acute. So that means this is 30 degrees. Now we have to go from here, though, and we have to go from 90 over here. Okay, wait a second. Use a protractor. Find the measure of angle BCA. That's 30 degrees. And angle BCD is 90. So this is 30 degrees. This is 90 degrees. Well, what do you think this is going to be? Right, because we know that the whole thing, this whole thing is 90. We know this is 30. So wouldn't we have to have this be 60? Doesn't that just make sense? So these two angles, this one right here and this 30-degree angles, those are complementary angles or complementary angles. Okay? Explain how the measure of angle ACD without repositioning the protractor. So that's what we just did. We know the whole thing is 90. If this is 30, then that's 60. Use the protractor in the picture to find the measures of LOC and LOM. Explain how you know it without repositioning. And I'd like you to try that one on your own. So I'm going to pause it, and I'm going to have you try it. So I'm saying this one is 37 degrees. It's really, it's kind of hard to tell, but I'm going to say that's 37. And we know that this whole thing, okay, so LOK is 37 degrees, and LOM OM, this angle right here, well, look at that. It's a line. So this one is 37. This one's 180. Without moving it, what do you think that angle KOM? So this angle right here, what do you think the measure is? How do you think we could find it? Hopefully you all saw that we could take 180 and minus 36 from that, subtract it from it. Pull out our calculators. 180 minus 37 is going to give us 143 degrees. Okay, well let's go this direction. If we go this direction and come over here and we look at the big one, yep, look at that, there's 140. So there's 130, 140, and then 3 beyond it, so it's 143. Okay, good. So use that complementary and supplementary to your advantage. Here we go. Angle BAC. So BAC is a right angle. What's a right angle? Right, 90 degrees. So this whole thing is 90 degrees. Okay, find the measure of this angle, CAD, this angle right here. What do you think we're going to do? Right, we know the whole big one is 90, and this part is 64, so we're going to take 90 minus 64. And I know I should be able to do that without a calculator, but I'm not good at subtracting. 26 degrees. Okay, look at this next one. Pause, try it on your own, please. Okay, so notice this is on a line. And on a line is a straight angle. So this whole thing has to be 180 degrees. Okay, and we know that supplementary angles add up to 180. So if this one's is 76, then this has to be 180 minus 76, which is 104. Raise your hand if you got that one right. Oh, I'd love to see in the room right now if you actually raised your hand. Okay, I'm just being silly, but that's just me. Okay, the good news is we're pretty much done with notes, and the homework assignment is short, so you're in great shape. So, just to remind you, and maybe pull out your highlighter right here, if two angles measure up to 90 degrees, then they are complementary. Okay, complementary angles. Good. And here are some examples. 30 plus 60, 45 plus 45, 52 plus 38. Okay, those are all 90 degrees. If two angles add up to 180, those are called supplementary angles. And here are 3 examples. This adds up to 180, and see that's a 90 degree angle and a 90 degree angle, so those are congruent. Here is 152, and there's 28. They don't even have to be adjacent angles to be supplementary. They don't have to be right next to each other. See, here they're across from each other. Here they're adjacent. They share a side. But the other ones, but they're still supplementary angles. Good. For your homework, you are going to do page 17, and you're going to do numbers 1, 2, and 4. Okay? 1 and 2 is the current information we're on. And number 2 you can do. Just take some time with that and look for angles. List 2 pairs that are complementary. Look up what complementary looks at. What is complementary? Aha. Okay. Then name 3 angles that sum to 180. Okay. Now to name an angle, you're gonna use 3 points for now. 3 points. Okay. So like this is the angle DAM. See this angle right here? Is DCM. Okay, so make sure you're naming them, and the vertex has to be in the middle. Now, I could have also called it MCD, and that's 27 degrees. So come up with those. We're skipping 3 for now. It's kind of a cool one. What you had to do is you had to combine like terms. You're going to get 11x, and then you're going to combine more like terms, and you would have gotten 11 minus 5.5. So what do these have in common? If I factor it out, what can they both be divided by? 11. Okay, so I guess we could have just done number 3 too. And we did. Number 4, match each table with the equation that represents a proportional relationship. So you have to find the constant of proportionality. How do I find it? Y divided by x. So find the constant of proportionality for each of these. And remember that if we write the equation, a proportional equation is going to be y is equal to kx. And k is the constant of proportionality. So once you find the constant of proportionality, you just plug it in there and you have your equation. You'll be done in no time. Good. Well, hope that helps. If not, jump on a Google Meet and ask me some questions. That's not a problem. I have one open right now. And even if it's not open in the room, I have a Google Meet open, so feel free to contact me. Thank you so much. And if you have questions, email me or jump into a Google Meet if it's during the school day. Thanks. And during your class.